Hello guys, you're welcome to our practical class again, and in this practical the drawing and the procedure is on your screen already, and we are going to be determining the refractive index of a glass prism. Here we have a rectangular glass block and we're going to be determining its refractive index. We have a drawing board, as you see here, a drawing paper, then optical pins, drawing pins, a rectangular glass block, a protractor, and a 30 cm meter rule, of course a pencil or an eraser in case there is a mistake. And as it is in the drawing, we are going to set up the experiment and carry out the instruction as it is in the drawing. First of all, we are going to draw or place the rectangular glass prism on the paper and trace its outline and label it A, B, C, D before we proceed. So I'm going to do that and follow the instruction step by step.
So here is the outline. As you can see, now that we have the outline, I'm going to draw a normal and then, okay, first of all, I'm going to label here A, B, C, and D. And then I'm going to measure out 2 cm from this end and draw a normal at that particular point, and then label that normal according to the instruction that was given to us. So let me draw the normal. Here is my normal as it has. I've measured 2 cm from A, and then at that point I found my normal, a point that is at 90 degrees to this particular AB line, and I've drawn it, produced it down. Now at this point I am now going to fix in, according to the instruction, a pin at this point here. Maybe I'll have to label this. Let me label here N, let me label here M, and let me label here P, so that our thing will be very clear. So now we have NMP. I'm going to insert 2 pins at point P. I'm going to actually measure out an angle of 5 degrees at P, and then insert a pin at P here and proceed. So let me measure out 5 degrees from at P. So this is what we have. You can see here that I have measured out 5 degrees, which represents our angle of incidence from the normal, and then this point where the incident ray makes contact with the interface AB, I labeled it Q. This is my M at the other end. So I'm going to be inserting a pin at point P and point Q, and then use 2 other pins and replace them along this area so that all of them will align at the same point. So this is what I'm going to do. I'm going to replace my block and then insert 2 pins at point P and Q, and then use 2 other pins here to replace them, and I will show you how it comes out at the end of the day. So this is what we have gotten. You can see the point P here with a pin and the point Q here just at the interface of the block, also with a pin. And I've also used this pin here, the 3rd and the 4th pins, to block the rays of light along that path. I'm going to show you the direction of the rays of light so that you will confirm. But be careful anytime you're conducting this experiment not to use this pin to dislodge the block from its outline. You can see that the block should always remain in its outline. Now, this is what we have when you're viewing this. You can see here that you can see if I shift, this is the point where all the pins align together. Now, if I move to my left, you are going to see through the block, you're going to see the 4 pins at different positions. But if I bring it at my eye level where I view through, now you can see that all the pins are in a straight line. We are only seeing one. Now look through the block, not above the block, because if you do that, you're going to see the other one at the back standing beyond the block. So this is what you have. You can see 4 of them, and then if I move towards this direction, you see that all of them are in the same direction. You can see. So this is what you have. I had to do this for this particular first reading. I may not have to repeat all of this through the experiment, But if I move to the right, you see also that all of them, they are disaligned. So they are all in the same line. So having done this now, I'm going to now remove the pin and the block, and then connect these 2 points to Q, and then we'll find the angle which this line I'm going to draw will make with the block, and we'll measure out using the protractor to record it as theta. So having completed my measurement, this is what I have been able to deduce. The value of theta gotten from my measurement is 82 degrees. Remember, initially we measured the angle of incidence to be 5 degrees. So in the question, we're asked to compute cos theta and sin I. So if we punched cos theta, it gave us 0.1392 and sin I giving us 0.0872. Now this is for the first reading for I equal to 5. I am now going to reproduce every step that I have taken here in measuring I 10, 15, 20, and 25 to get it a total of 5 readings. And after that, we will now tabulate our readings, plot our graph, and follow the other instructions according to the question under consideration. So let's draw the outline for the second one. For I equal to 10 degrees. Okay, we have set up the second experiment here, and then we've measured out the angle of incidence here. You can see the line under the block as 10 degrees, and we'll put our pins P and Q. Remember, we measured from here to be 2 cm, and we'll put our pin P and Q at the edges there by minding also the interface, making sure that the block is correctly along the lines. And then we have also used 2 other pins here to obstruct the rays of light along the lines of the pin to align all of them in the same direction. So we are going to just confirm to see that all the points has been aligned. So let's just check out and see what we have. So at this point, I believe you can see the rays of light. Now as I move it to the left, you can see that all the pins are just standing differently. Now let me move it to the right. As you can see, they are aligning at this point now. You can see that it's only one pin we are seeing. So this is the point where all of them has aligned. Now the other one you are seeing there is across and it's on top. So if I move it to the right, you can see the 4 pins through the block. Always look through the block, right? So you can see, so we have this. I'm now going to go ahead to measure. First of all, remove these 2 pins. Let me remove this, and all of these pins, and then mark and find out the angle theta according to the question. So this is what we have after the second reading. Remember that our I is 10 and our theta gave us 75 degrees, and then we punched the cos of the theta and the sine of the I, and it gave us all these values, 0.2588 and 0.1736 respectively. And then we proceeded to the next point, which is I is equal to 15, and this is what we have been able to set up. The same, we just replicated the same procedure. We just measured our I. You can see the angle inside the block here as 15. The 2 pins are also inserted. The distance from A to M is measured as 2 cm as according to the procedure. And then we have 2 pins here that we have used to replace the 2 pins, and making sure that all of the pins are aligned. We would also simply just show you what we've been able to do. So let's view from the side. Now you can see from this side, moving to the right, you can see the 4 pins through the block, and then moving to the left, you can also see them. Then I come this way, you can see that all of the pins are aligned in one same direction. So once we have been able to achieve this, then we can now go ahead and measure. So I am quickly going to remove the pins, remove the block and the pins, and then connect these 2 points to this point Q, and then measure the angle with the block interface, and then we'll proceed to the next one. So here is the final result from our third reading. This is our first, second, and the third reading. See our I, which is constant, 15 degrees. Our theta we measured is 69 degrees, and then cos theta, when we punched it, it gave us 0.3584, and then sine I gave us 0.2588 for 15 degrees. So, and here also we have proceeded to produce our fourth setup. You can see that the same procedure has been repeated. I is in this case 20 degrees. The two pins are also inserted at the edges, and then two other pins has been used to replace them. Now let us view through and see what is the outcome of this particular experiment. You can see to my right the four pins disjointed. Let's go towards this direction. You can see also in this direction you will see the four pins also not aligned, but let's move towards here. You can see that all of the four pins are in the same direction through the block. So we're only seeing one. So at this point, we will only have to dismantle and measure the angle theta, which the line will make with the interface AB. And then we'll do the last one and tabulate our reading. So let's quickly do that, and then we'll show you the table. Okay guys, as we begin to wrap up, this is what we've gotten. For the fourth reading of I equal to 20 degrees, we have our theta measured to be about 59 degrees. And then by punching cos theta, we got 0.5150, and sine of the angle of incidence I, which is 20, it gave us 0.3420. So proceeding to the last one, we've also set up the experiment as usual, following through from what we've been able to do. You can see the complete setup here, following through from what we've been able to do from the first measurement. The width or the distance measured here is 2 cm. The points are PQ, where we inserted the pins, and then two other pins has been used to replace. Remember that anytime you're viewing, you have to view with one eye open and one eye closed, so that you can be able to see accurately. So let us confirm this last one, what we have. So if you view from here, you will see the four pins, and then as I'm moving towards my right, you can see that all the pins are now perfectly aligned. So that was how I saw. You can see we're only seeing one pin. If I move anywhere, any inch away to the left or to the right, you will see that they are not aligned. So you can see at this point, all the pins are aligned and as if they are one. So this is the final measurement. So I'm going to now remove everything and measure out, and then from here we will now tabulate all of this on the table and then make our final deduction. So finally, here is our result. I 25 degrees, theta we got as 50 degrees, cos theta gave us 0.6428, and sine I gave us 0.4226. So this is how we've been able to measure out our readings in this particular experiment. So I'm going to put everything that you have here on a table, and then with this we can be able to proceed to get the graph, the slope, and then answer the sub-answer questions that follow. So you can. Okay guys, so this is what the table represents for our experiment. You can see on our table the various components that we measured during the experiment: the I, the angle of incidence, the angle theta, which is the angle that the emergent ray made with the block. Theta is also recorded on the table here. Cos theta, they asked us to evaluate, and sine theta, and they are all represented on the table appropriately. Now they asked us to plot a graph of cos theta against sine theta, and when we plotted that graph, we got a straight line graph that almost passed through the origin. As you can see here, it's a neat graph that shows to a large extent that what we did during the experiment was very correct. So our slope in this particular experiment is expected to give us the refractive index of the glass, and then by the time we computed the slope, we got our slope value to be equivalent to 1.51, which also tells us that the material we used for this particular experiment is glass. So it confirms to you that our refractive index is actually very correct. So this tells you to a very large extent that our experiment was very perfect. As we all know that the refractive index of a glass, of course, it can vary depending on the material you're using, but 1.5 is a very good value to get for the refractive index of a glass. Anything that away from this, maybe above or below, can be accepted depending on the magnitude. If you get something around 1.4 point something or 1.6 around there, is also very much acceptable. So this will tell you, or rather it will confirm to you the refractive index of the glass that you particularly used during the experiment. The precautions that we took, they are standard. Neat traces must be ensured, pins must be wrecked, and then you avoid parallax error in any measuring device that you use during the experiment. The protractor and the meter rule must always be used, and parallax error would or should be avoided. Then, because we did experiment around refraction, we are asked to state the laws of refraction. We have two laws. The first law states that the incident ray, the refracted ray, and the normal at the point of incidence all lie at the same plane, while the second law, which we call snellslaw, states that the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant for a given pair of media. That constant is referred to as the refractive index of that particular medium. So these are some of the questions that they asked us. I believe that this experiment was very straightforward for you, showing you how you could be able to deduce the refractive index of your glass prism. So you can try it out and see whether the glass prism that you have has a standard value, or that the refractive index is a little bit outside the range of acceptable values for a glass prism. Thank you very much. I believe that it has been of help to you. Please do well to always like and share the videos as you receive them. God bless you.